Welcome to another episode of Together Talks, a series of conversations with researchers and industry leaders about generative AI brought to you by Together AI. I'm Tri Dao, Chief Scientist of Together AI and a professor at Princeton. Today, I'm thrilled to be joined by Huyen. She's a writer, she's a computer scientist who has lived many lives, from growing up in Vietnam to exploring Asia, Africa, and South America. Her journey has been as diverse as her accomplishments. She's a Stanford graduate, she's an educator, she's also Amazon #1 best-selling author in AI, and she's the founder of Claypot. And right now, she's the VP of AI and open source software at Voltron Data, working on GPU-native data processing and open data standards. Welcome, Chip.
Thank you so much for having me. I'm really excited to finally have a conversation with you. I've been following the work for a long time.
Yeah, I'm really excited about this. Yeah. So let's start with at the beginning of your academic journey. So when you were at Stanford, you taught this class on machine learning systems that was really successful. I heard a bunch of really great feedback from Stanford students about your course. I'm curious, how did you get started with that? What motivated you to start that course?
So actually, I really enjoy teaching. So I find that teaching is really, I feel like my students probably could not inspire or confidence to hear this, but I find teaching a great way to learn. So whenever I teach, I felt like I learned a lot from, maybe more from my students than they learn from me. So don't tell them that. So I think it's so I started as more of a TA at Stanford. So you went to Stanford, right?
Yes.
Undergrad?
I actually did both undergrad and PhD at Stanford.
What class were you?
2016.
Oh, okay. So wait, so our time overlaps.
And I think so.
I never met you. That's crazy.
That's a pity.
Yeah, I feel like, I don't know, when I was there, I felt like there were not a lot of Vietnamese students. By the way, we're both Vietnamese.
Right.
So we were just bonding over it. Yeah. And I was very happy to hear that he speaks Vietnamese.
This is great. Yeah.
So do you know about section leading at Stanford?
Yes. So that's for undergrad computer science classes. It's like TA, but for undergrad TAs, right?
Yeah. So when I was there, that was the only opportunity for undergrads to do some kind of TA related job. So I try out and I really enjoy it. And then at that time it was in 2015. And Google TensorFlow came out. At the time it was the hardest thing ever, you know. And I was just I really want to learn about it. So I was using TensorFlow for one of my internships. And I went to my professors and asking can we have a course on it? And of course professors don't have time on it, right? Creating a course is a lot of work. And then people told me that actually at Stanford they have this kind of program called a student initiated course. So my students can propose a course and teach it. And of course, you need approval and do a lot of check and measures around it. You can only cap it at 20 students. So I started it. And so it was mostly a group. I wanted to find a small group of people to learn TensorFlow with. It worked out pretty well.
That's amazing. So so were you preparing the course and how did the process work if you're kind of learning TensorFlow at the same time as teaching?
It was pretty stressful, honestly. So I realized I'm not very good at public speaking. So when I first came to Stanford, I was very insecure with my accent. So I was very nervous. But so I was just trying to learn a lot more about TensorFlow, spend a lot of time prepping. So my roommates had to suffer through all my it was practicing. It was you just have to sit down and listen to me. So I'm very grateful for my roommates and a lot of friends helping with that. The professors were extremely kind. I think the students understood. I think I was being very open with them about that. They know that I was a student. So I think it was fine. But it did teach me a very important lesson because when I taught the course, it went pretty well the first time. And then I wanted to teach the course again next year, and then TensorFlow changed to TensorFlow 2.0. And I was if I was to teach it again, I would have to redo 80% of my material. And I was I will never again do something that's tool related. Right? I just don't want to do. I know there's a lot of good materials out there, but creating is one thing, but maintenance is another, right? It's very similar to building software. You do something dependent on third-party tools. You just basically at their mercy. So that's why we had an idea for the system design course, but I want you to approach the problem from a more fundamental.
I see.
So
it's
I wanted like
more general.
Yeah. So it's more of like, I think the problem solving would never go outdated.
I see.
So I want to focus on like what are the important problems and what are different approaches to solve them. So like certain techniques will change over time, but in general, like approaches is like, it's just not many ways to like change, right? So
yeah. So that sounds really interesting, because there's always this feeling that AI is moving really, really fast, and we have a lot of people in feedback like, hey, should I be learning this stuff? Is it going to be relevant this year or next year, right? And so in your experience, what has changed since you were teaching this machine learning system class, and what hasn't changed?
It's really interesting because so I'm also writing another book. So when I was like referring to my older materials, and I felt like a lot of core concepts have not changed.
Okay.
So so when I was so like when I graduated, like it was in like 2018, and I thought it's like, what are the really big problems in AI? And it was like, first is like hardware, and the second is data. Right. So
that sounds familiar. Yeah.
Yes. Yeah. So I was like, okay. So my first job was NVIDIA, because I really wanted to learn about GPU, and then I joined Snorkel AI, like to work on data. So I feel like it just has not changed at all.
Oh, that's true. Yeah.
So I was thinking. So I think even back in 2015, 2016, I was working on language modeling, and that has not changed. Right. So I think I remember when I was back then it was like machine translations was like the hot topic, right?
Yeah.
So back then it was not very good. So of course things got better, but like the approach, like the importance of machine translation has not changed, right? I do think this like model architectures can change over time. I think back then, I think I was telling you the story of like a method about like this company who was like developing hardware for LSTM, like specialized
this
in
must have been 2015
2015. It was very ill-timing. So I think like architectures can change. I know that like you're working on a very exciting new model architecture.
Right.
Yeah. So I think certain things can change, but I feel like a lot of fundamental, like the building blocks, like don't really change. You're still using optimizers, right? You're still thinking about like how to make things run faster. So I think it's like making things better, faster, cheaper will never go away.
Yes.
Yeah.
Yeah. Yeah. I think there are a bunch of these like maybe fundamental understanding and skills that can endure, and maybe it's the hard job as an educator to prepare this course is like figuring out which are the fundamentals and which are not, right? So your teaching experience led you to writing this book, Designing Machine Learning Systems, which is I think #1 bestseller on Amazon. I'm really curious how that happened. What was the process was like?
It was a pretty natural process. I never set out to write a book.
Okay.
So I'm very big on note taking. So I take a lot of notes. And when I taught my courses, I was worried that my students could not understand me. So I tried to prepare a lot of notes. So just in case they don't hear my accents, they could still refer to the notes. And over the years, I just like had like a lot of notes. And also together it was like when I was working, I also made a note on like things that I learned along the way, and actually like published it like on GitHub. Like it was a very
just notes on GitHub that anyone can see.
Yeah, and I think it did pretty well. So combine everything, and eventually it was like it looks like a book. So and then it was like, why not publish it?
Yeah. How was the publishing process? Going from hey, here are a bunch of notes, PDFs you can download, to like having a book and being like a best-selling author.
Thank you. I feel like best-selling for a technical book is not quite the same as like best-selling is like normal book, but I'm very happy, and I'm very grateful for the opportunity. So the process was pretty straightforward. So you talk to publisher, you send them draft. So I work in like iterations. I feel like writing a book is very similar to like building a product, right? So you get things out, and then you get feedback, and then iterate on it. So actually, I come from writing background. So I was working as a reporter, journalist in high school.
I didn't know this.
Yeah.
Wow.
So I have been working with a lot of editors, and so I just know over time that's what is easier to edit and what is not, right? So it was so one thing I find very easy, like things. things is like style, voice, wordings, like cosmetics, it's very easy to change. But what is really hard is like structure.
Yeah.
So over the years, I'm trying to think of like the structure first. For example, like there come on like technical structures. For example, my favorite structure is why, and then how.
I see.
Yeah. Right. So I think that's like a lot of time people. Or like it comes to like reading as well. A lot of time I hear books and like, okay, what is this? What is XYZ, right? I think it's the wrong question to ask. I think it's like has to like, why is this, right? So I'm just trying to understand why, and instead of like when I understand why, I try not to jump straight into techniques and try to see like what's the common patterns among these different techniques. Yeah. So it's one example of like model merging. So was it looking more emerging? It's very interesting. I saw that Together Compute recently had
we've done some research on
agents.
that.
Yeah, that's pretty cool. And I was like looking a lot of like model merging reviews, like writing, and I felt like people jump straight into like, hey, this is like theirs, this is Thai's, and I was like, yeah, but how long this technique's gonna stay, right? If you just like keep this right up, it's gonna be outdated. But I was thinking like, what are the main approaches to like model merging? So I thought about like, okay, one is just like, I think it's like a summing. Like you have like two models and just sum them up, or like average them out, like weighted sums, right? Yeah. The other approach is maybe like stacking them up. I have one layer from this, another layer from this. So stacking up now is pretty common. You have like mixture of expert, and then you have like upscaling. You have a model, smaller model, right? And now you want a bigger model because now you have bigger hardware. Like instead of training a bigger model from scratch, can you take this smaller model and then like maybe duplicate it, right? Or let's make it bigger. So I thought like, okay, so maybe is that a good like way to think about it? And then another, I think it's less popular, is like concatenations. Just like putting them side by side instead of stacking them up. So I was just trying to like find like what are the common patterns and like what is the pros and cons of the big approaches. Right.
So it seems like some of these patterns kind of come back again and again. Do you think you know when you were trying to write the book, do you have a specific audience in mind? You're like, hey, I'm writing for this kind of engineer or researcher or this kind of student. What do they need to know? What do they need to know like 5 years from now? What did you have a specific audience in mind when you were writing this book?
Would it be very selfish to say that like I have myself in mind when I write the book? So I think it's like the best time to write about a topic is when you're just starting learning about the topic, because like once you've been really familiar with the topic, it's kind of become boring to write about it. Right? Yeah. I know there's people who
have certain blind spots, like maybe things are obvious to you, and you've kind of forgotten that it used to be complicated, right?
So when I learn about something, I make a lot of notes, and then when I go back and like more like an edit and like adding things for myself about like when I started our journey and what kind of things could I have loved to learn back then. Yeah.
Right. And so you're obviously you've done a bunch of things that are quite different. You've done writing, writing books, making courses. You've also founded companies. So you founded Claypot, and now you is part of Voltron Data. So how did that happen? How did you get interested in startup and founding companies?
You have done a lot of things as well, right? Like
I've done some, but I'm super curious about your journey.
So I think it's like everyone does a lot of things. I think it's for me, I'm just more interested in like, well, what are the problems? So I don't think I set out to be like, hey, I want to be like, have a diverse set of experience. I was more like, oh, this sounds like an interesting problems. Like, how do I learn more about it? And they're actually all interrelated, right? Because, for example, I actually started out from math. I had a math background, so I spent like the first many years of my life, 12 years of my life, just doing competitive math. Actually,
that sounds fun.
Did you do that?
I did some competitive math. I mean, I always enjoy that, but maybe it's not a cup of tea for everyone.
I enjoyed it a lot when I was younger, but then I was realized, but then after a while, it's just like, I want to do more. I want to see more, like what is out there outside of math. Yeah. So I feel like it does come in very handy to understand like models, architectures, or like especially in probability is extremely important.
Yes.
So statistics understand is for like people keep asking like why do model hallucinate, or like different evaluation methods. A lot of them require like a good statistical background. And then I realized that writing really helps me with like trying to like understand the concept better, because I realized the philosophy is not mine. I forgot who said it. Maybe a lot of people have said it, but it's just like you don't understand something until you can explain it to someone else.
Right.
Yeah.
Maybe it was Feynman or someone. Yeah, but this sounds familiar. Yeah.
Yeah. So so it was just like I feel like writing comes in really handy for both like just writing things down or teaching, because I do think that students understand things better when you try to like present them as part of the story. Yeah. So I think they all come together.
So you were excited about certain problems, and maybe the way you approach the problem was like, hey, I'm going to learn about this stuff, I'm going to teach it. Maybe some of it was like, hey, I want to do a company in this area so that I'm...
It's not about like company. Okay, so maybe in a better way to phrase it. So I was like, over time, I'd recognize different blind spots. And it was just like, what could be a really good way for me to like learn and address these blind spots.
Okay.
So I was working as an engineer. I was doing some research for a while, and I felt like I have a pretty good grasp of like technical, but it was like I don't understand at all about the business side of things.
Okay.
So I felt like, is there a way for me to like learn more about that? So I feel like a lot of things that I do, or like about like managing people, like people aspect is like way harder than the technical aspect. I'm not sure, are you managing people right now?
I mean, yeah, some. I'm kind of making the transition from kind of doing a lot of research myself to kind of working with people, getting them excited about certain ideas in certain directions, right?
Yeah. So I think that's just different blind spot, and I was just like, what are the kind of things that I could do to most effectively help me address my blind spots?
Wow.
Yeah.
And so when you founded Claypot, and then now as part of Voltron, so you're now working on GPU data processing.
Yeah.
How did that happen? Because you said, you said you were like your background's in math and then courses. How did you get interested in this problem of data processing with GPUs?
So I was thinking, it's like, what would be something really interesting to learn right now? It's like GPU optimization. So I think when I was at NVIDIA, I worked more on applied research. So we were working more on like the software aspect. I never wrote any kernels when I was at NVIDIA. And I think like we started a company, and then ChatGPT came out.
Right.
And so the model is just getting like rapidly bigger and bigger. I felt like in GPT-2 it was like 117 million parameters.
Right.
And the time was considered big, and then it's like hundreds of billions of and it was like, I know this NVIDIA has been an incredible company, and they kept like pushing the batteries and like how fast the computation is, like memory bandwidth and everything. But the model was just growing like crazy as well, and I felt like it would be very important to learn how to like optimize, like doing GPU or like Gero accelerator optimizations. Yeah. So that's why we decided to like join Voltron Data. Yeah. I feel like, I just want to be in a good place to be surrounded by people who know about like certain topic I want to learn about.
Yeah, there's some really interesting stuff going on as I read about this stuff. Like you've been talking about how different data abstraction can affect the efficiency of the data processing system. Maybe like if you want to engineer a data processing system that's going to run on GPUs, maybe you need like very different abstractions. So how does that work? Because that sounds a little bit counterintuitive to me, that some of the data abstractions need to be kind of catered to the hardware. What would be some of those examples?
So I think that it comes from like very different directions. So like the reason I got interested in data processing, because I felt like is a under invested in area. Okay. So I think this like GPUs ever since has been using for like deep learning research. I think it's AlexNet.
Right.
2012.
Yeah.
So ever since then, GPUs have been mostly focusing on using like training and inference. Yeah. And I was like, how about this whole world of like ETL data processing, right? Like we have a massive amount of data, and sometimes it's like we don't even have enough GPUs for training and inference. Nobody has GPUs left for like data processing, which I don't think is true. Because like we can always have like more and more machines, more CPUs, and we can have like maybe like faster, newer generations can be used for inference and training, and then later generation, like older generation, can be used for data processing.
I see.
And I think that data processing is very suitable for GPUs because a lot of data processing jobs are very naturally parallelizable. Right now, if you want to process a billion rows of data, I can just farm it out to a lot of cores on GPUs. And we do things that for CPUs is only certain so CPUs we think it's not going to top out it's just only certain scales that CPUs can reach. You can't just put a lot of CPUs together and like indefinitely scale, right? At some point, it's
there's these systems like MapReduce, Hadoop, and Spark, and so on that was like doing massive data processing on CPU. But you think maybe like GPU is much more well suited for this kind of task?
Not all kind of tasks, right? So we have to look at different kind of like queries to process. So like it's an joins or it's an aggregations. So certainly like there are a lot of good benchmarks for it. So I think it's like it was a good way to learn. So even though like GPU optimizations for inference training and data processing is the same, the kernels you have to write for them are very different. And as you have written like a lot of kernels, right? You pretty know it's like it's very tricky. It's not that straightforward.
Yeah. And so as you you have these kind of maybe counterintuitive way of thinking about things. With Spark and Hadoop, people were just all in on CPU doing data processing, and you're like, hey, let's use GPUs for this stuff. What's really interesting to me is that like you kind of have this more fundamental understanding of what's really going on. And I think recently you mentioned that, for example, a bunch of new stuff in generative AI people are really excited about, but actually some of the techniques have been there for a while, somewhat counterintuitively. So why do you think people got excited about this all of a sudden if kind of a lot of the ingredients were already there?
So I do think there's like several trends that allows it to happen. So first is just like maybe just one key thing is models are now available as a service. So that means before, right, like if you want to like use AI as a product, you actually have to build models yourself. But now you can just like anyone can just make an API call and like use AI, and everyone can build some like demo or like product very, very quickly. So I've heard like many stories of like people when I spend a weekend. I think you have one of them on your team, right? Like spend a weekend building a product.
Yeah, they could be like, I don't know, a search engine, AI powered search engine or something like that.
Yeah, a very, very specialized product. And so this like is a good thing, because it allows a lot of people without machine learning background to use AI. But at the same time, because we have a lot of people who don't have like background in machine learning, so maybe they don't really have a lot of like history or like understand. I'm trying to say, I don't want to come off like you need machine learning. I know there's a lot of wonderful people who have built like wonderful applications on top of AI without understanding AI. But I do think that like it can also have like create like blind spots. Like people are not aware of what have been done in the past.
Right.
And that makes a lot of things just seems like shifting sands or like new, where in fact has been around for a while.
Right. Yeah, I think you also mentioned like a bunch of the classical machine learning techniques shouldn't be abandoned. People shouldn't just focus on the new LLM stuff. A bunch of older techniques are relevant. How do you see people, or how do you think people should be using some of these more classical machine learning techniques with these new models?
So I've seen this in a lot of systems I have looked at. Like the vast majority of them have some like classical machine learning algorithms. So one very big thing is retrieval today, right? Like RAG system, and like search and retrieval have been around for so many years. I think it's like even back in like 1920s, people were describing like the digital retrieval systems. I think like Stanford have some professor like Chris Manning has his book on like retrieval, like information retrieval.
Yeah, he wrote a textbook on this stuff.
Yeah, he's incredible. So I think it's like there are a lot of like it has been around for a long time. Like I think like BM25, like Elasticsearch can be used for a lot of stuff, and it's actually really hard to beat like BM25, right?
Yes.
Or like vector search, even though we see a lot of vector databases, vector search itself is not a new concept. So like that's one thing. So I feel like a lot of concept from like search recommender systems actually very relevant to NetRack. When working with embeddings or like lexical, like a term-based search, or about like even like with now we're dealing with like memory for like AI systems, right? Like now we have a long conversation with the AI, and the AI have to pick out like what is important about like that person that they are like conversing with, right? I'm not sure you're working on it yet. So I do think it's like it's not a question of memorization; it's a question of building out a profile of that person's, right? So I think it's like that person can maybe saying, oh, today I like eating X, tomorrow I like eating Y. Like you can memorize all of that, but over time you have to like create like, okay, maybe that person prefer cheaper restaurants, like or like prefer people like restaurant in this locations.
So you can build out a profile, like doing some kind of inference on the user profile, right?
Yeah. So like a lot of this is like building out this profile is actually a very old important problems in the recommender system, right? You need to build up profile people to be able to recommend things to them. And things will be the same way, right? So for example, like I was using ChatGPT a lot, and I just like sometimes I get annoyed because they just keep saying things that I clearly just don't need to hear. So for example, like asking them to explain the problem, and if ChatGPT doesn't know who I am, right, it can just like go to very general.
Like, it doesn't know your preference, right? Yeah,
I was like, but I already know this, right? I wanted to be in very concrete technical answers, but sometimes you need to prompt it. I feel like it's getting better because now like OpenAI introduced like memory. But I do think this like search recommender system is extremely useful. Another way I see it being used is that for routing and intent classifications. So you might not have just like one model to like serve all the queries. For example, you have a customer support system, right? You might first detect like what is this query about, because sometimes like somebody was telling me about a coffee shop they went in Toronto, where they have like a coffee bot, and that coffee bot just like refuse to answer any questions that's not about coffee. Which I think is great way like for like safety guardrails, right? Because like a coffee bot shouldn't have to talk about like the elections. So one of the first thing you might want to like put a model to detect like whether this is a question about coffee or not. So like defining the out of scope questions for the bot is very important. So you can use classical classification model for it. And then once after that you might want to like detect like what is this about? Is this about like billing? So maybe you can route into billing department or like a billing bot like specialized in talking about it, or like a technical troubleshooting. Then you have like a bot specialized in it. So I think it's very common. And another is like scoring system. So like it's a guardrail about like whether the quality of the response is good enough, whether it's relevant to the question being asked, whether it's like safe, right? Does it have any toxicity like detections? Does it reveal any PII information? So say you have a retrieval system to retrieve from internal database, and maybe it's like fetch some like sensitive information, and somehow it's like seep into the So I feel like a lot of way you can use classical machine learning with the system.
It feels like these LLMs are kind of this central kind of intelligence engine, but like everything else around it that needs to be that you need to integrate with the existing system to do any kind of task that has economic value is all like classical machine learning.
I think of it as just like AI is just a tool. And there are different tools, like this tool is maybe like sharper, this tool is a bit like heavier, it's like a hammer and a knife, right? They might be able to do different things. It doesn't mean just like they can't be used together. So I do think of AI today is more it's just part of like the software engineering stacks that we have. Like it's used similar to like databases or like JavaScript. Now I think of like AI engineering is more.
I think we're gonna get there. I think one of the main challenges, we haven't really figured out what is the right abstraction to kind of interface with these models, right? So far we've been kind of interfacing with them through just natural language, and they're prone to hallucination and so on. And for some people, they say it's a showstopper, but you don't seem to think so. You seem to think that even some of these models, maybe they hallucinate. Like there are ways to kind of build around some of these weaknesses that these models have.
So I think it's like depends on like what do you consider hallucinations. So hallucinations, I do think it's like one. It's not always a bad thing. I'm into storytelling. I'm into so I do things. It's like I love it when models being very creative and like creates things that I don't think of. It's really cool to see a lot of artworks like you can create with AI. So I don't think it's a bad thing. Right. I think it's like hallucination is an issue when for like tasks that demand factual correctness, like factual consistency. So I think of it as like. So the issue is not really hallucinations, but the issue is like factual inconsistency.
I see. So yeah. How do you explain the difference between the two?
Hallucination is more as like just maybe generative things that don't necessarily exist. Okay. Whereas so it can be a good thing or bad thing depending on the use case. Whereas factual inconsistency is like maybe that is a factual, and the response is not factual. Right. So like I think of it as like what I consider factual consistency depends on what the facts are. So let's say it's like I give you a story, right? Like I make up a story, and the story says the sky is like purple, right? Okay. And now I want to ask you like, hey, what is the color of the sky in this story? Right. So like if you say the sky is blue, right? Yeah. Then even though it's like globally.
But it's not consistent
with the story, right? So I think it's like, so you need to understand what's the context here. So I think it's like one tricky, like I do think it's like, so I define them as like local and global factual consistency. So local factual consistency, you have a set of facts, maybe a document, a story, and now you just need the model to be consistent with that, right? But global consistency is about like just like generally accepted facts. So for example, like you ask like, hey, does vaccine cause autism, right? Then you need, so like the model has to look all around the internet and its knowledge base, or like from its training data whatsoever, right? Or like we call this is like innate knowledge, or like I forgot the term, my brain is just like blank out. So the model internal knowledge that it acquire from training. And I think it's like global consistency is really hard to like verify, because you first need to require you to like determine what the facts are. And when you look at the internet and with all kind of like conflicting information, it's really, really hard. But whereas like local consistency is a lot easier. I don't think it's like really, really easy, but it's way, way easier. So have you noticed like I'm not sure you noticed, but like when I use ChatGPT, instead of like asking like, hey, what is this about? I try to provide it with like, here's a list of papers you can reference, and use those papers to answer questions. And I find like it's answer pretty good. So I think that might be the use case that a lot of enterprises who are worried about hallucination go for, and just provide it with what consider
retrieval or from RAG or things like that, right?
Yeah. So if we see this, like you work a lot with RAG, right?
Yes. So it seems like you've been thinking a lot about kind of how to build applications on top of these models, right? And it's hard to imagine these models not kind of changing the way we build applications. And I know you're working on a book on something related to this AI engineering. Could you tell us a little bit more? I know it's not out yet, but I would love to hear a little more about the book you're writing.
So I'm very into system design. So I like thinking about how to solve the problems, like how to build a system that solves the problems. So I'm less interested in like learning about a specific topic unless this techniques like help me solve the problems I care about. So my last book was like designing machine learning systems. So it was out in 2022, and it was I think it was focused on like the fundamentals of like building machine learning system in general. And this book builds on top of it. So it won't cover what that last book's already covered, but it does like focus a lot more on challenges specific to generative foundation models.
Yeah, and how did you last time for the last book you were like, hey, I want to learn about this stuff. I'm going to write a course and a book about this. So how did this second book happen? Was it the same process as the first book, or was it something different?
It's actually really different. So this book didn't come from a course, but it did come from like a lot of notes. I guess in a way the process is similar. Just like you don't have a course attached to it. When ChatGPT came out, I had a little bit of like existential crisis. Yeah,
How so?
You did not?
I thought it was amazing, but I think from a research point of view, I think GPT-3 was kind of the defining moment on the research side. Kind of for the first time, they kind of show that scaling works really, really well. I think ChatGPT as an application, kind of on the engineering application, is huge. But I think even the OpenAI researchers didn't think or didn't anticipate it being that big of a phenomenon.
So it made me realize it's like how can just change like the framing of like how a tool is used, and it's completely changed like the perceptions, like reception of it. So it was just like really incredible to me, like how much impact you can have if you know how to use like the models the right way. And so it was like I really need to like really spend time understand it. So I just spent a lot of time looking into that. I'm like a little bit like have a little bit of obsessive behavior. So like when I'm into something, I really, really want to understand it. So I went to look at like a lot of papers, but so like just like a lot of manual labor. So so for example, like it went through looking at like thousands of different like repos, like going through the code base, not very detailed, but like over time you kind of have a patterns of like, for example, like if you look at a model repo, right, you look into a model py or something like that. So like they're trying to get into like what's the difference between these implementations or like different tools and trying to understand how they are being built under the hood. And I feel like I just made like so many notes, and I think some of them like will convert into like blog posts, which I feel like got pretty good receptions, but it's not really the reasons I was writing more. It was just more like through the people question, I just realized it's like maybe people found this like maybe found the same problems as I saw, and also I got a lot of good feedback through the process. And was like, now I have like this so many notes, and so many people I correspond with, and we talk is like, I think I maintained correspondence with like various ML teams, but like 50 companies.
Wow, that's crazy.
It's very useful. I think they all have a lot of problems are unique. I do like go out my way to seek for like unique problems.
Right, but does it help you kind of distill some patterns, some of the common patterns or fundamental problems that these people are having?
Yeah. So I think it's very clear early on that my RAG was like knowledge augmented was very important. It's very clear very early on is just like evaluations is very, very important. What wasn't clear early on was like how important prompt engineering could be, or like what was. So it's really funny, like when I started planning out the book, it was like, okay, we need 3 chapters. One for prompt engineering, one for RAG, one for agent. And then I realized like, oh, actually they are very much like related. Right, because they owned with the patterns of like allowing the models to gather information to answer questions, so that you don't deal with like changing the model itself. So like prompt engineering is like giving very good instructions. So if you have very good instruction, maybe you don't need to like provide a lot of examples. Examples always help though. RAG is just like to connect to database and you can provide more information. But also agent is like the pattern of like performing actions. So I think the action have like read actions and write actions. And agent I'm talking about here is like more read actions, like you go and like browse the internet.
I see. So using tools and things like
to
that.
like gather information. So like they own the pattern like helping the models gather sufficient information to actually answer the question, right? And then I think like the next phase of like agents is like using right action and let model to perform actions. And it's like it's scarier, right? Like for example, like giving the model the right to perform like select queries is very different from like giving us a right to like do delete query on a SQL
Maybe you
database.
need a much more higher level of reliability for these models. So for developers or people who are interested in AI, what are some of the areas you would recommend them to start hacking on or building on? Should it be hacking on open source projects? Should it be learning prompt engineering? What are some of the kind of low hanging fruits that they can do?
I don't think the first thing to ask would be like what problems they want to solve. Because like I read somewhere it's like very interesting advice. I forgot who said it. It was like it's a lot harder to change industry, to change company than to change job. So like say it's like like if you're a company, right, you have a role you don't like, maybe you can switch to another team. Or if you have like a tech company, you can switch to another tech company. But it's a lot harder to change from like one industry to another. So I think of like problem is like it's very big things. It's like if you can choose a problem you want to solve, you can stick with it for a long time.
Right. So your advice would be figuring out what problems are really interesting, really exciting to you.
Yeah.
And then figuring out what tools you need to learn to tackle those problems. I see.
Yeah.
And how do maybe different kind of environments would or different types of companies would favor different kinds of problems. So some people would prefer to be in big tech companies. Some people would prefer to be in smaller startup, like founding their own startup. How does that map onto what kind of problems they're interested in?
So there's problems they're interested in, but also like what skills they want you to learn, because some problems are so big that they can just approach it from like multiple problems, right? And I say if you're interested in bio, like building, for example, like extend longevity. I'm just coming up with some random thing. I'm not saying I'm interested in it, but it seems like it's a very big problem, right? You can either become like a doctor, right? Like study chemistry. You can also use AI. You can go into more of like traditional biotech company doing gene sequencing. I don't know, like there are a lot of things you can do. So it just felt like it was a big problem. You want to focus on like what you want to learn. So if you join a big company, it's likely that you only focus on a very small part.
I see.
Which is not a bad thing, though, because a big company allows you to also have access to a lot of people and also give you more freedom, so that if you get really tired of a team, you can go and join another team. Whereas at a smaller company, you wouldn't have a bigger scope, but you have less access to people. So you can see more things, and maybe a smaller company have less opportunity to work with, to see like how the tool is being used. Like say if you work for Google, right? You can see one tool you can build, you can have like 1 billion people using it. You can see like so many different usage if you can see it. But whereas at a small company, maybe you have like a few customers and you pretty much like just have to focus it. But you have to see this from a bigger lens. So I think it really depends on what you want to learn. And of course, they have very different financial payoff equations. So I think it's like, I thought about it recently, it's about what kind of big problems a person wants to have, like has in life and want to solve it. So there are some problems that are like more, bigger. So I'm not sure about you. So I think it's like there are things that's like, you can think of it as like building a safety net. Like if you solve the life big problems, then you have more safety net that allows you to like solve other problems. So for example, like finance is one big problem in life, right? If you feel like financially secure, that would allow you to take more risk.
I see.
Yeah. So it depends on what phases of life and whether finance is a big concern for you. Or when I first came to the US, immigrations like visa, green card was a big problem, right? And I felt like I also need to like decide my next step based on like how fast do I want to solve these problems.
Right. So maybe like there are some risks you want to minimize first, and then once you kind of have that safety net, you can have a lot more freedom to kind of pursue the problems that are really exciting to you.
Yeah.
Right. Yeah.
Yeah.
Yeah. It's incredible. Like you've succeeded at so many areas, writing, founding startup, teaching technical stuff. What do you think is kind of the secret to being so successful in a bunch of areas.
I don't think English code is very successful. We live in the Bay. I feel like success here, I've seen people with like crazy success. So I feel like a lot of things I do, I feel like it's pretty not optimal. I think it's like, I was thinking about it, it's like, if you want something that's like career optimal, you stick with one thing and become really good at it. Whereas I felt like I jump around, and whenever you change the focus, you kind of need to like do a lot of things from scratch. You can build on top of each other, but there's always a little bit of cost for like switching. And I think it's like, I have known people who just stick with one thing. First of all, they did math and just stay on doing math forever, and they're incredible. They do, some of my friends in Vietnam, or like they do writing, they have a lot of success with writing. Like they write book, and now they write TV shows and like movies, right? Like a lot of success, and they have their own production company, which is incredible. I feel like I just jump around, and it had a lot of cost, but I learned different things. Right. So it really depends on like what your interests are. I do think one common things that really help is one is just like being able to tell a good story. Okay. So starting a company, like so I don't think it's like what as a CEO you have like two jobs. One is fundraising, and the other is hiring. Yes. So so they both need to write, like tell really good story. You need to tell story to VCs, like why does this thing matter? Why is the best person to do this? And hiring is like you tell the story to people, like why they should join you. Instead of like having a cushy job at like Google. So that's like very good story. Another is just like asking the right questions.
Yeah, these are really good advice. These are really, really insightful. Thank you so much, Chip, for sharing your incredible journey and insights with us today. It's been an enlightening conversation to our listeners. We hope you enjoyed this episode. Stay tuned for more engaging discussions on Together Talks.
Thank you so much for having me. I'm a little sad that I didn't get to ask more about our work. I've been a fan of the work for a long time. I'm really excited to see more work coming out.
Yeah, let's definitely chat more.